So welcome to this latest video on 162 Maths, and in this video we'll be going over the AS Maths topic of algebra quadratics and with a focus of looking at the discriminant. Now if we use the quadratic formula to find the solutions of the following equation of x squared minus 3x plus 3 equals 0, then we have a bit of a problem. Now the problem with this is the fact that when we substitute it into the quadratic formula we end up with this expression in which what we end up with is the fact that we have a negative number inside our square root, which is here. Now this is, we can't square root a negative number, so what does this actually mean? Well, this means that the equation will have no solution. So if we go and plot this quadratic, which is going to be a positive parabola, then what this means is the fact that I'm going to end up with an equation where the minimum point or the parabola does not cross the x-axis, so therefore this would have no solutions. And this also applies to any quadratic equation that when we substitute it into quadratic formula, if it produces a negative number into the square root, it will therefore have no solution, so therefore the parabola does not cross the x-axis. Now the expression of b squared minus 4ac is what we call the discriminant of the quadratic, and is often symbolized by the Greek letter of delta. Now if the discriminant is less than 0, then what, as previously mentioned, that the parabola will not cross, whether it's positive or negative, cross the x-axis, so therefore produce no solutions. If the discriminant is equal to 0, then what we end up with is, let's say we end up with 3. So if I just get my pen working, what we end up with is 3 plus or minus root 0 over 2, and if the square root is equal to 0, then this here becomes pointless, so all we end up with is the fraction, in which then that's going to be always positive or negative based on whatever our value of b is going to be, and so therefore it's going to just produce one solution. If we end up with a discriminant that is greater than 0, then we're going to end up with two distinct values. And what that looks like is this. Now this is definitely something that's worth considering and putting in your notes. So by calculating the value discriminant of the quadratic equation, we can establish how many roots or solutions it has. Now if b squared minus 4ac is less than 0, then as previously said, it's got no solutions. If b squared minus 4ac is equal to 0, then it has, we say it's got one solution or one repeated root. If b squared minus 4ac is greater than 0, then we say it's got two distinct real roots. And if the question says that it's got real roots, then it could either have one root or two real roots, in which the discriminant is going to be greater or equal to 0. So let's have a look at our first example. So the question asks, evaluate the discriminant and tell us how many roots the equation has. So for this, it's not a case of making it equal to 0, so here we just have a quadratic expression. So all I need to do first is state what my coefficients are using the quadratic formula. So my a is coefficient of x squared, which is 1, b is a coefficient of x, which is minus 6, and our constant value is negative 8. So then using the discriminant formula, which is b squared minus 4ac, I'm now going to substitute these three numbers into my discriminant. So what I have is minus 6 squared minus, now I always like to put brackets around the 4 times ac, only because if a and c are negative, it just helps eliminate any particular errors that may involve with negative numbers, particularly as you've got a minus outside of the 4ac. So here we've got 4 times 1 times minus 8. So then from this I simplify, so I've got minus 6 squared, which is 36, minus 4 times 1 times minus 8, which is negative 32, leaving me with an answer of 36 plus 32, which equals 68. And so what's important for me to then write is, as my discriminant b squared minus 4ac is greater than 0, there are going to be two real roots. And we don't need to state what those roots are. It's not asking us to solve this expression, particularly as it's not equal to 0. It's just asking for us to find the discriminant value, which in this case is 68. So I can write delta equals 68 and explain what that means, and it means then we've got two real roots. Moving on to our second example. So again, very similar in terms of the question as our previous example. So here we just need to write down our coefficients. So a equals 3, b equals -1, and c equals +10. So then writing the discriminant values, we then have that delta equals, and it's going to be -1 squared minus 4 times 3 times 10, which is going to equal 1 minus 120, giving me an answer of -119. So as b squared minus 4ac is less than 0, we have no real solutions. Moving on to our third example. So here again we have a equals -1, b equals -3, and c equals +10. So b squared minus 4ac is going to equal -3 squared minus 4 times -1 times 10. So the discriminant is going to equal 9 minus, and it's going to be -40, and that's going to give me a discriminant value of 49. So as b squared minus 4ac is greater than 0, we have two distinct real roots. And again, you could just get away with writing there's two solutions or two distinct roots or two real roots. Is entirely up to you how you write your answer. So now let's have a look at this worded exam style question. So this exam question says, find the exact values of k for which the quadratic equation kx squared minus k plus 2 lots of x plus 3 equals 0 has one repeated root. So let's break this question up. So this question, we know how many roots there are, so there's nothing for us to find. So as it has one repeated root, what we know is that b squared minus 4ac is going to equal 0. So what's left for us to then do is again state what the coefficients are. So k is the coefficient of x squared, which is a is the coefficient of x squared, which is k. B is the coefficient of x, which in this case is going to be minus k plus 2. Now the reason why it's written like that is because the expression has been factorized with respect to x, so the coefficients will be all of that. Now another way, if you're not liking the brackets, is to expand the brackets, so I can write this as minus k minus 2, and my constant in this case is going to be 3. So then substituting this into the discriminant, which I now know has got to equal 0 because I know it's got one repeated root. So here what I have then is if b squared minus 4ac is equal to 0, then what we're going to end up with is minus k minus 2 squared minus 4 times k times 3 equals 0. So what's left for me to then do is recognize that this is k minus 2 minus k minus 2, and again using whichever method of quadratics factorizing, expanding the brackets you use. So this is going to give me k squared plus 4k plus 4. So I can rewrite this as k squared plus 4k plus 4 minus, and it's going to be 12k equals 0. So from this I can then simplify, so I get k squared plus, well that'd be minus rather, minus 8k plus 4 equals 0, and then all that's left for you to then do is solve this quadratic for k. So again I can use my calculator to work that out, in which I get a k value of 7.46 or 0.547. and they are to 2 decimal places. Then moving on to our second example, it says find the set of values of k for which the equation 2x squared minus k plus 1x plus 5 minus k equals 0 has 2 distinct real roots. So again, this implies that the discriminant is going to be greater than 0. So using this to find the coefficients, a is going to equal 2, b is going to equal minus k plus 1, and c is going to equal everything that hasn't got an x, which is 5 minus k. So then substituting that all into the discriminant formula, we end up with, and I can write this as minus k minus 1. So I end up with minus k minus 1 squared minus 4 times 2 times 5 minus k, and that's greater than 0. So simplifying all of this, recognizing that this is double brackets, so minus k minus 1 minus k minus 1 is going to equal k squared plus 2k plus 1. So that's going to equal k squared plus 2k plus 1 minus, and it's going to be 8 lots of 5 minus k, which gives me k squared plus 2k plus 1 minus 40 minus 8k. And just be careful with the negatives here, in which I'm going to end up with minus 40 plus 8k is greater than 0. Then simplifying all of that, k squared plus 10k minus 39 equals 0. Then going on to solve this, we get a k value of 3 or minus 13, in which just spotted a mistake, that should be greater than. So if we go back and we state what our critical values are, which are 3 and minus 13, and it is really important that you state what those critical values are. I draw my diagram. The k quadratic is going to produce a parabola. This is minus 13, this is 3, and then it's the values that I'm wanting is where it's above 0, so it's this region here. So my k values are going to be less than minus 13, or k is greater than 3. So if you're wanting to have a go at the next 3 questions, feel free to pause the video and then unpause and see if you get the right answer. So let's have a look at these 3 questions. So for the first one, we know that with number 1, we know b squared minus 4ac is going to be greater than 0. So my coefficient values are going to be 3, b is going to be equal to 5, and c is equal to minus k. So substituting numbers into the discriminant, I get 25 minus 4 times 3 times minus k, and that's greater than 0. So I get 25 minus, would be plus 12k is greater than 0. So 12k is going to be greater than minus 25. So k is going to be greater than minus 25 over 12. And there's my answer for number 1. For number 2, we know it's got no solutions. So b squared minus 4ac is going to be less than 0. My a value is minus k, my b value is 5, and my c value is 3. So substituting those in, I get 25 minus 4 times minus k times 3 is less than 0. So that equals 25 minus 12k is less than 0. So 25 plus 12k is less than 0. 12k is less than minus 25, giving me a final answer of k is less than minus 25 over 12. And then for C, question 3, it's got no real roots, so that means then it's going to be b squared minus 4ac is less than 0. So A is 2k, B is 0, and C is minus 3. So substituting those in, I get 0 squared minus 4 times 2k times minus 3 is less than 0. So what I end up with is minus, and that's going to be 8 minus 24k is less than 0. And that becomes a plus, so it becomes 24k less than 0, which then gives me an answer of k is less than 0. So moving on to this example here, it says y equals minus 3x squared plus xk minus 12. Find the values of k for which y is less than 0 for all of x. Now this particular question is worded slightly different, but it's virtually the same question. So here we have our quadratic equation. In here we have what we want it to equal. Now both those things are equal to y. So this is another type of way of writing this. And we want that where it's less than 0. So in other words, what we're looking for is where this has got no real roots. So then finding the value of A, which is minus 3, B is positive k, and C is minus 12, what we end up with is k squared minus 4 times minus 3 times minus 12 is less than 0. So k squared minus, and it's going to be minus or plus 144 equals or is less than 0. So k squared is minus 144 less than 0. This is a difference of two squares, in which we get this is less than 0. So my k values are going to be positive 12 or negative 12, and these are also my critical values. So if I draw my parabola, this is minus 12, this is 12. I want where the curve is less than 0, so I want this region here, and so k is going to be in between minus 12 and 12, exclusive of those values. So now let's have a look at a past exam question. So the past exam question says the equation of kx squared plus 4kx plus 3 equals 0, where k is a constant, has no real roots. Prove that k is in between and inclusive of 0 and exclusive of 3 over 4. So again, looking at this, we know it's mentioning no real roots, so we're looking at discriminants. So b squared minus 4ac is less than 0. So if I pick out my coefficients from this expression, I get a equals k, b equals 4k, and c equals positive 3. So from this, what we end up with is 4k squared minus 4 times k times 3 is less than 0. And then we want to go on and solve this. So here we end up with 16k squared minus 12k is less than 0. Then we can then factorize this with respect to 4k. So we end up with 4k minus 3 is less than 0. So then k equals 0, and it's going to be 3 over 4. So then from this is also my critical values. So drawing my parabola, which will be a positive parabola, I've got 0 and 3 over 4. And I'm looking for the region where it's below the x-axis, so I'm looking for this region here. And from the diagram we can then write that k is between 0 and 3/4. Now you may notice that in the question it also states that k can also equal 0, which seems quite odd compared to previous questions, as we know that a discriminant that's got no real roots is going to be less than 0. Now the reason why we can include an equal 0 for k is because if k does equal 0, then what we would end up with is 3 equals 0, which is not an equation, which therefore has no real roots. There's no real answer to that. So that's the reason why k can also equal 0. But again, if you've got your diagram, you can then think back to what they want you to show, and that would be the case. There's no need, it didn't ask you to explain why k equals 0, but if k was equal to 0 and you substitute it in, it would also produce x equals 3, which can't happen, and also there, by definition, will give us no real roots. So let's have a look at this next exam question. So for the first part, it says express 2x squared minus 20x plus 53 in the form of completing the square, where we've got p and q to find. So if I take this first bit here, so ai is take out the 2, so we end up with x squared minus 10x plus 53 over 2. And then I can then use my methods of completing the square. Minus 25, in which then I can multiply everything by 2, in which I get 2x to the minus 5 squared plus 53 minus 50, which gives me 2x minus 5 squared plus 3. It then says use your answer from part AI to explain why 2x squared minus 20x plus 53 equals 0 has no real roots. So there's a couple of ways in which you could answer this. So from this, we've got a minimum point at, and it's going to be 5, 3, which is above the x axis. So therefore, it's got no solutions. Or another alternative way you can do is go on and try and solve this equals 0, in which we'd end up with equals minus 3, and then we can take the 2 over, and then you end up trying to square root, so you can't square root, oh, I'm going off screen, so you can't square root a negative number, so therefore it's got no solutions. So just little right here, can't square root a negative, so no solutions. And hopefully you've got more room on your sheet than I have. So that's your answer for part AI. In fact, let's just move this up a little bit so we would have had a little bit more room. Now for B, which isn't really connected to part A, so it says the quadratic equation has real roots. So real roots means that b squared minus 4ac is going to be greater or equal to 0, because real roots could either mean one real root or two distinct roots. And the question is asking us to show this quadratic. So what we end up with is a equals 2k minus 1, b is going to equal k plus 1, and c equals k. So then knowing that b squared minus 4ac is greater or equal to 0, substituting this in, we get k plus 1 squared minus 4 lots of k, 2k that should be, plus minus 1 times k, and that's greater or equal to 0. So expanding that out, we get k squared plus 2k plus 1 minus, and that's going to be 4k, 2k minus 1 is greater than 0. So we get k squared plus 2k plus 1 minus 8k squared minus 4k. And again, just be careful with the negatives. So collecting all of this, we get k squared plus 2k plus 1 minus 8k squared plus 4k is greater than 0. Simplifying all of this, we get minus 7k squared plus 6k plus 1 is greater or equal to 0. Then if I take all of that over to this side, I end up with 7k squared minus 6k minus 1 is 0, and the inequality is pointing at the 0 at the expression. So here is going to be my answer for AI. It then says for part 2, find the hence possible values of k. So if I use a different colour for part 2, I then just need to solve this equation. in which I can use my calculator for that. So I've got 7 minus 6 minus 1. So that gives me critical values of 1 or minus 1 over 7, in which that's also my critical values. So drawing my diagram, I've got minus the 7th and 1. I want the area where it's less than 0, so I'm wanting this region here, and that gives me a final answer of k is less than 1/7 or k is greater than 1. And let me just make sure that that's clear on the screen. So k is less than minus 1/7 or k is greater than 1. Then moving on to our last question, it says, given that for part 1, given that y equals x squared minus 5x plus 15 and 5x minus y equals 10, show that x squared minus 10x plus 25 equals 0. So for this, all we need to do is substitute our linear equation into our quadratic. So for I, if I rearrange the linear equation, I get y equals 10, and that's going to be plus 5x, in which then I get 5x plus 10 equals x squared minus 5x plus 15. Take all of this over to this side, in which we end up with x squared minus 10x plus 25 equals 0, which is what they wanted me to show. Then for part 2, it says find the discriminant. So for this, we get that a equals 1, b equals minus 10, and c equals 25. So I end up with minus 10 squared minus 4 times 1 times 25, which gives me 100 minus 100, which equals 0. So what does that mean? Well, it means then that we have one distinct root, or one repeated root. And what does this mean in relation to the question? Well, it means that the line 5x minus y equals 10 is a tangent to the equation of y equals x squared minus 5x plus 15. And there we go.